Okay, part two of our background build and sprite movement. So we'll start on that. What we're going to do is from part one, we're going to unpack that picture, display it on the screen. Then we're going to use a sprite, a little rocket we're going to put on there and move it around with a program called Twisty02. So if we look here, there's a sprite we're going to use. The only difference with it is I had to change the color. If you look up here in the corner, it displays white. And remember that Twisty that we're going to use the background, its background was white also. So if we displayed them together, you wouldn't see nothing but a few dots on the screen. So I've changed the background on the actual sprite to a gray color, if I believe. So anyway, let's start by looking at our code for. It's called Twisty02. Again, this is the way I did it on the first try. May not be the best way. I don't think it's the best way, but it's a way that works. And I did use this way back in P mode 1 or 2. I know I tested with this way back in the 80s. But we'll take a look at it and may give you some ideas on how to display a background. Okay, just another program. Got an offset here. We'll talk about that later. We're going to have to use this offset of A00. We'll talk about that later. Got some things I got down in the direct page, down the first memory page for speed. We'll put these few things here that really get hammered on quickly when we're displaying the sprite. Our program is going to be down at E00, where most of them are. We'll start it down there. Start out, we'll initialize a few fields. Going to rocket address where to display it on the screen to start with, and a loop counter. We'll loop through our main routine. We'll loop through there 60 times and then we'll call it quits and go about a bit. Rest of it looks like stuff we've done in the past. Turn off the interrupts, save our stack, move our stack down, give it a new address, a high-speed poke, and disable some other interrupts on the MMU chip. And this thing's here, use blocks 30, 31, 32. Now, if you recollect when we were looking back at where the display is, it was 30, 31, 32, and 33. And that is correct, except for we're using 192 by 256, and that only takes 3 pages to display. Okay, it's not, if you was doing 320 pixels wide, it would use that 4th page, but we're only using 3, so it only takes about 6K, about 24,000 bytes, something of that nature. So we can do it in 3 blocks, so that gives us a little bit of speed. Okay, block 0, we're going to put that in A, and we're going to store that in our task 1, our task register, AD. Remember, block 0 is where that basic program loads the picture, our compressed picture that we did earlier. It's going to go to block 0, so we know we got a pointer to it, and we're going to load up a 1 and store it in FF91, and that popping that, and it says now we're in task 1, so we're looking at what task 1 looked like. Okay, let's back up a skosh and say what task 1 looks like. This is what it looks like now that we popped it, other than right here at FFAD, we put, instead of having 3D in there, we put 00 in there, so that memory block 0 is sitting there. Here's our display. We're only using 3 of them, but it's 4 of them in there, so that's what we're looking at. Our program's down here. So just to refresh a little bit, and we'll walk through this to see what we do, what we did in the other program, and how these programs communicate with each other. Remember, in the Twisty program did the compression, the C program output, it passed along 5 key things: where the picture was located inside the program, where the palette was located, where the background color was, and the rows and columns. So here we're going to load up X with the offset. Again, the offset up here we said was A00. Okay, why was that important? Because we just put block 0 in A00. So now we're addressing that block. And remember, it arged at 0, so it's at the bottom of that block at A00. So that's our offset. Now we're pointing, oops, get down here. we're pointing exactly at the beginning of that program has the picture in it. First thing we do is we're going to load up D with the address of the picture. If you remember right, back there it was at, I believe it was at 001A. It pointed to the picture inside that program. We had to offset to it, and so it's now we're at A01A, so we're pointing to the picture. We'll store that address, so we'll have it for later. Next thing we'll do is we'll load up where the palette is located. We'll do a little loop here and copy that new palette out of that program. We've got our background color here. Again, all these are the communications between these two programs. We'll get the background color, we'll save it right here. We'll get our row and column, we'll add the offset, and we'll store that. Now, so we've got all the communications from the other program. We know where everything is, now we can go to work. Right now we're going to do things like we've done in other programs. We're going to go copy off the old palette and put the new palette into play. And we'll clear the main screen. The main screen right now is sitting in blocks 30, 31, 32. And they are sitting at 2,000, 4,000, and 6,000. So we'll go down here and see if we can find the clear screen somewhere. Clear screen. Okay, our beginning of our screen is down at 2,000. So we'll load up the background color in A, the background color in B. So now we're covering, remember each one of these is 2 pixels. So we're really doing 4 at a time. We store D at X and bump and just doing this loop real fast until we get up to the end of the screen. And we'll go back. So that we've cleared our screen. We haven't displayed anything yet because we haven't popped the register that says display. All we've done is got things ready to go and we've cleared the screen. Now it's time to unpack that screen and actually put it on and display it. So the address of our picture, remember we just got that up here. We talked to the other program and it told us where it's at. So now we know where the address of that picture is and where do we want to display it. Okay, we know our blocks 30 is at 2,000, so we'll put 2,000 in U and we'll go to the routine called show pick. And oops, if I can get this broken mouse to work correctly. Show pick. Okay, display the picture in blocks 30, 30, and 32. Okay, this is the code that we extracted from CoCo SC, exported through the C program, and we're going to unpack it now. So we'll keep the screen address that we just put in the red strip there. We'll load D with what to do. Okay, that's a ambiguous term. So I'm going to take us back for a second to, this is our program. This is what we're pointing to now. Okay, consider this is at this 01A. We're at A01A in the program, and it wants to load D at what to do. So it's going to load these 2 bytes in here, what to do. Okay, remember I told you that we this was all encoded, and now we're going to pack it based on them codes. So let's go back to twist D02. So we'll load up what to do, compare D as we at the end at. No, we're not. So if it compares to 5080, which encoded in there is a skip 128, and if we look at this again, the very first entry is 5028, and all that says is I got a line that matches exactly to the background color, so there's no sense piddling around and unpacking something if I'm already matching the background color, because we cleared the screen to the background color. So just skip ahead and go forward and do something else. So if it's equal to that, we say bump to the next line, and next line, all the next line does is bump it by 128, which goes down 1 line and goes back to the top, grabs the next entry in that picture table, and just so happens in this one here, the next one also is 5028. So we got about 20 of them in here, blank lines at the top of our picture. Sooner or later, we're going to get through where it's going to fall through. Now we're going to check and see what do we got. What is the command? Is it copy 1 byte, copy 2 bytes, copy 3 bytes, or 4 or more? And the reason to 1, 2, and 3 because there's no payback by having a long drawn out thing if we're copying in bytes, because you cost you more to copy one byte by using the other routine. So anyways, just saves at 4. You're even money on expanding it. So it just basically it says, okay, what I want to do, if I got here, if it was happen to be 3 bytes, I'll just store B, which has in the encoding it has the character display, and it stores B plus 3 times there. So I just put 3 of them characters on it, branch to end, and all end does is say, am I at the end of this line? If not, go to the top. But if we look back here, each one of these entries, okay, you'll see this one here has an 80, 128, and this one here is an 80, 68, 8. That bit on there says this is the end of this line here. So I've done everything I can to decompress it. I'm at the end of the line with whatever character is now go on and do something else. So we've unpacked every character, go through all 192 lines, just goes right on through, just keep zooming through each line, one line, until it's done. That's very, very basic, rudimentary compression on each line. No bit manipulation whatsoever, rocket science type stuff. So, okay, so now we're somewhere down here, get back to where it was. We just unpacked that picture. It's on, I call it the main screen. It's in blocks 30, 31, and 32. It's sitting there. Still haven't displayed anything yet, but we're getting ready to right now. We're going to load up a default screen addresses, and we're going to branch to a routine that says set this mode for this. Okay, we'll look at that. And then we'll do a lot more of this in other videos, but not here, okay? I'm not going to tell you what all these bits do here. We loaded up this IM graphic. I took this right out of Unraveled Basic, because this is how they do it, and it's very, very unique and compact, and it works. This first byte here, this 4C, we'll talk about that in some other video, exactly what that means, them bits, and what all these other bits do here. But anyway, so this 4C and 80 basically says we're going into graphics mode. The 1A equals 256 by 192, 16. And there's about 20 or so different combinations you come up with that would go in here to come up with what the screen is. And there's some other information that's in there that has nothing in it. And then we got the address where it's displayed, and that's the graphics screen address, not our memory screen address, but where in the MMU is at C00. Okay, so we do that, and here's the routine. It does it. It reads one of these bytes, it stores it, and it does this little loop and stores them in there. And when we're done, we have just popped it. Now our image that's sitting at 30, 31, 32 is now on the screen. So we finally got something on the screen after we're here. So now it's image is loaded, it's on the screen, and you can actually see it. Okay, here's our main loop. Our loop count we set at the beginning, I think it was 60. We're going to go through here 60 times. So we'll decorate the loop count. Is it equal to 0? No. Go on. And here we don't need to, well, you understand, okay, we're going to sit here in this little loop waiting for the V-sync. That's the vertical sync. We don't want to do anything while it's in the middle of drawing a line. You know, it draws all the scan lines across. And I'm going for, not as an expert in this, but I just kind of know what it does. Drawing all the different scan lines, starting at the top down to the bottom. And when it gets to the bottom, we'll get a sync. Okay, so that's the time now we can display another screen without getting that flicker in the screen that I think you've seen with some things. So we'll sit here and wait until the sync is done. Otherwise, it's just going to loop once it's done. Now we can go to work. Okay, we got a field up there called buffer. Which buffer? Because we're going to be using 2 buffers. We're going to be flip-flopping in between different buffers. Remember, I showed you the buffers earlier. We're going to increment the buffer. It started at 0. We're going to increment. Now it's got a 1 in it. Now we load A with the buffer, and we and off and say, what do we have here? So if it's got a 1 in it, and we got a 1 here, okay, the result's going to be a 1, so it's not equal to 0. We won't take the branch. So what we're going to do right now is right here. We're going to display buffer 1 and work on buffer 2. Well, buffer 1's on the screen. Everybody's looking at it behind the screen. Now we're going to update buffer 2, we're going to put our Sprite and our little rocket on there and go about our business. So first thing we want to do now is display buffer 1. So we're going to load up where that buffer is at. Okay, so remember I just told you when we started up originally it was C00. Well, now we're going to move it down to our other buffer 1, which is at 28, 29, and 2A. So I'm going to move this screen over here, and this little formula here, take this the block number times 2000 divided by 8 will give us what we want, and that comes out to be A00. So that's the number that calculates out, so that's what we'll use. We already put C00 in there, so we don't need a 0. And here I just said store the A0 part, not the 00. We could say store D and put it in there, same thing. It's going to get in 9 in the correct address. So now, as soon as we did that, we just popped, excuse me, buffer 1 is now being displayed. Now we're going to do this move. Now I don't know if anybody caught this or not, but we just had not an error, but a oops, boo-boo moment right here. Okay, we're going to display buffer. Well, has anybody done anything to buffer 1 yet? I didn't do anything to it yet, so we didn't get buffer 1 set up. All we did was flash it on the screen. So any garbage that's in memory in buffer 1 is going to display instantaneously. And we're going to do some stuff, and then we'll be going to buffer 2, so we'll be okay. But we should have cleaned out buffer 1 first. I fixed it in the next twisty program. And this one here, I caught it later on when I displayed it, and I said, I'm just going to leave it fixed that we can talk about it so you understand the problem. Okay, and there's a few other problems in here, but that's just one. It's program will run, it's just not, it doesn't look right. Okay, so now we're going to branch to a routine called move to that says refresh buffer 2. All right, we haven't done it with buffer 2. We're going to refresh buffer 2. So we'll go down here to, where did I go that wrong here? Move to. Copy from main screen to screen 2. Okay, remember we showed it originally. We'll go back and in life and look at that again too. Okay, remember our main one is at 30, 31, 32. Buffer 1's at 28, 29A. And buffer 2 is at C, D, and E. Remember, we're not using the other buffers on account of we've got a smaller buffer area. So move to. We're going to load up our. We should have looked at that just a tad longer. We want to copy 30, 31, 32 into 2C, 2D, and 2E on this here. We want to refresh everything's in here, copy it over to these buffers here. This is our task now. So we'll put from buffer is 30, or 2 block, or in our 2 is 2C, and branch to a routine called the move. As we actually do the movement. So here it says copy 2 to there. Okay. So to move, and again, a note, we only need 3 pages. We don't need all 4, so there's no sense moving an extra 8,000 bytes. We don't need to. First thing in here, it says move it. So we branch subroutine. We branch subroutine. Again, we're branching subroutine, something called move it. Move it says store D. A D had in it, the 2, or the from and 2 blocks in it. Store that in our MMU registers A and D. And that's got A00 to BFF to 2C to DFF. Again, we're going to take a trip back, and this is what we're doing. We're putting this one and this one in them registers. And all we're doing is just a loop here. Load up U with A, X with C00, and just loop and move them 8,000 bytes. It's okay, hex 2,000. We're going to move them real quick, done, and return. Come back right here and it says add D hex 101. What did D have in it? D had 30 and 2C. So we're going to add 101 to that. So we're going to add the 1. It's going to end up with 31 and 2D. So that's the next 2. Okay. Did you get that? Okay, I hope so. And we branch again to move it, and move it loads use nim blocks, does the same move. Come back here, we add another 101 to it. Now it goes up to 3, 2, and 2E, and move it again. So we move another 8,000 bytes. And I asterisked these actually, remember, we don't need that last 8,000. And so therefore the move is done. Now we've copied the screen over, and now we need to actually use it so we can actually manipulate the screen ourselves. So we're going to load up the block addresses 2C and 2D, store them in the MMU register in the task 2 area into A9, load up 2E and 2F and store them. So now when you're in task 2, you'll be pointing to buffer 2 that has a fresh copy of that screen. Okay, so we just did move 2. So now we've got a fresh copy in buffer 2. Now, over here in this notes, it says draw a junk line in buffer 2. And that's just for testing purpose. I left it in there so you'll be able to see it on the screen. Load up D with 2222. Okay, we're going to use palette register 2. I think it has some kind of a gray color or something, and it was residual in there. And address on the screen is at 6,000. Remember, our buffers are at 2,000, 4,000, and 6,000, the 3 buffers we're using. Okay, so we're going to come 2/3 of the way down the screen at 6,000 and store D, this 2222. We're going to do that 7 times. Each one of these is 4 pixels, so we're going to do 28 pixels of a line just to show where we're at. Excuse me. And then we're going to do a branch to do some Sprite stuff. Okay, Sprite stuff. Load X with rocket address. Now that's I should have straightened that out. I've known this is a wording problem. It's not the address of the Sprite like it says is. It's the word is on the screen to display the Sprite. Anyway, bad wording on my part. And then jump to a subroutine called rocket E. E is left over from another presentation I did on stack blasting and stuff like that. And I had 5 different copies, A, B, C, and D. And this is the same copy of E I copied to CoCo. So we'll look at displaying the rocket on there finally. Okay, we're just about here, rocket E. This is a blitter method with transparency. Okay, so load up U with the address of the Sprite. Again, here's the Sprite. This is what we're going to display this on the screen. Now I'm going to go here pretty quick because, well, we're going to use this for the next 3 or 4 programs that we're going to look at. We're going to use the same routine. Okay, get the address of the Sprite, load U, it has the width and height of it. We're going to store that in these 2 X and Y counters. We'll push A, which is the X counter, and this is just a loop. It's going to go through this loop, 128, 8 times 16. So we'll load up A with what's in the rocket, in the new byte in the rocket itself. We're going to load up this very first 44 here. And we're going to work with that now. We'll push it and save it. And now what we're going to do is we're going to split it apart. Remember, each byte has 2 pixels. So we're going to take the first the first pixel and segregate it from the second one. So we'll have it split apart. One will have the most significant bits, and one will have the least significant bits. Okay, so we're going to do that. We're going to take A, we're going to split it. We're going to get rid of the least significant bits, these zeros here. We're going to keep the 1 pixel here. We're going to store that in the new most significant bits. Pull our A back up off the stack and do the same thing, just reverse it. We're going to keep the least significant bits. So now we've got that new one split apart. Now we're going to load up the old, what's on the screen there now. We're going to load it up and we're going to split it apart into old and new. So now we've got 4 separate entities we're working with. Okay, so we end up here with the A we're storing in the old LSB. We're going to compare what's in A. Well, here we got a note here. If this compare is different and the new is equal to the background. Use the old, else use new. Okay, that sounds like some good basic or C code terms. Then we're going to compare A, the new to the old, least significant bits. If they're equal, it doesn't make any difference. We're going to use either one because it's equal, so there's no change. We just branched out here to keep it. If there's a difference, we're going to do some compares based on this statement right here. And eventually we're going to store it into new both. It's going to have both the most significant and the least significant in here. So we're going to store A on whatever this was determined here. Now we're going to work with the most significant bits, the MSBs. We're going to do the same thing. We're going to do some compares, and based like on this saying up here, do that. When we get done down here, we're going to end up with keep MSB. So instead of saving it, we're going to OR it with what we stored up here. We're going to OR it back over what we just determined here. So now we've got both pixels back together, and we either got the new screen or the old screen for our transparency. We got it in A. We're going to store A on the screen and bump to the next position on the screen. We'll decrement our counter, which is our X counter. We're going across the screen, 8 bytes, not equal 0, branch to loop 1, grab our next new byte out of our rocket sprite, and go through the same thing. Go through it across here 8 times. When we're done, down here, we'll bump it by 128, go to the next line, and go through there until we're all 128 bytes of that particular sprite is done. We're just loop, 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 splitting it, comparing it, and ORing them together. And we now have the rocket is on. It's not showing on the screen yet, but it's in that buffer. Okay, that was Brandon. We was in there to do some sprite stuff. Okay, so we displayed it on. It's in the buffer. Now we load up this rocket address, which is our display address, which we just displayed it on there. We're going to add to it. We're going to move over 2 bytes or 4 pixels over to the right and store it in a rocket address for the next person that uses that address. I asterisked this out because during my testing I had a temporary little routine down there somewhere. It just slowed down so I could see here. I could see what was going on. So, where was that? Sprite stuff, okay. And now we're done with our store that. We're going to go back to the main loop. We come back to the main loop. We'll decrement our loop counter. Wait for our sync. Okay, now we'll do this buffer, and this time here we'll take this show buffer 2. We'll come down to buffer 2, which is like buffer 1. Here it says a display buffer 2, which we just remember we just updated buffer 2. We put a line in it and put the rocket in it. We'll do this 2C. This here we'll move over and show you what this one here equates out to B00. Okay, we'll do bang that, and now the screen we just built with the sprite on it and the line, so we pop that there, it's displayed on the screen and you can see it. Now when that's on the screen, we're going to do refresh buffer 1. So it's the same thing as buffer 2 minus the line. Okay, it's the exact same code. So when it's done, come back through. Next time we will display buffer 1. Only thing different about buffer 2 is this, remember, it's been moved over 2 bytes or 4 pixels over, so it will display in a different place. We'll refresh that screen, display the rocket, and then go on. Next time we'll back to this buffer. We'll refresh the screen completely. That's all 24,000 bytes. That's a lot of movement, but this is just an example in a test. We'll redraw the line and do that. We'll just keep going through there until finally our loop counter will get to 0 and we'll branch to end. Okay, and imp here is temp in, load up task 0, store it in F91. We're back to our original, the way when you turn the machine on, and we'll sit here in a loop waiting until you press the key, or the Q anyway. Once it gets the key, excuse me, you're at the end of the job, and we'll restore stuff the way it was when we found it and go back to basic once we're done with all that stuff like we've done in the past. So that's what this amounts to. So let's take a look at, if I may find it. There we go. Good, find some. Okay, remember that was our program that we got there, our basic program that put our picture out in that block 0. Okay, so we'll run this and we'll do that, and we'll also load our program that we just looked at. So we'll run this. That puts our picture out in block 0. And once it's loaded, our program. Now, I want you to watch this close because I don't think, remember I told you our problem was we didn't clear out our buffer originally, our screen. So whatever garbage is in there, as soon as we execute this, the very first time you see it flash, you're going to see whatever garbage may be left in there. I don't think, because if we run this and then we run it again the second time through, the garbage won't be there. We'll have this there. So second time run it, it'll be okay. So I'm going to hit execute and we'll see if garbage does pop up. Well, you didn't. I don't know if you've seen it or not, but it did. Okay, and anyway, there's our rocket moving across, and look at the line down there blinking. Remember, one buffer had the line, the other one didn't. Okay, there was our 60 quit. So I'll execute it again now. You won't see that flash this time because the buffers, well, we just got through using it. Okay, there's our rocket going across. You can see the background is all transparent. And our line is flashing. So when buffer 2's up there, we see the line. When it's not there, we don't see the line. So, and quit one more time. So all that talk we've been doing for a long time, we finally got something there. There it goes again. You can see, remember, you can see through it because there's the transparency there, so it doesn't interrupt anything. It's both of them are showing. All right, this is just one way that you can display stuff on the screen. Now, there's no delay loop in there, so it's not very fast because remember, between each frame that we displayed every time we flipped the buffers, we moved 24,000 or so bytes. It's not very efficient, okay, but that's just one way of displaying stuff. There is ways around it. Just assume if you've got a background, not this thing here, just say you got a background that has sky and water and ground or whatever you may have in there, and you're really only your moving rocket is only in the middle section. You're not in the sky or down on the ground. You're just in the water, okay? You would only have to move that center section. You wouldn't have to move all three. You could only have to move that 8,000 bytes in the middle, which would be much, much faster. Anyway, there's just another way of doing things. I'm just showing you. This is way number 1. So if we go back over here to, guess what? Twisty 05. I had a Twisty 1. It was a disaster. I just started coding and, well, anyway, it worked, but it was comical. It wasn't the best coding I've ever seen. So anyway, Twisty 1 went in the garbage can. I went to 2, then I went to 5. All right, this is pretty much the same program. Hopefully we can get through this one much quicker. This is all the same up here, same down there, stack, interrupts, blocks, doing this so far down through here, we're all the same. Here we're talking to the same program. Now here's where it's interesting. Remember, this is in a sense a different program, but it's going to talk to that same picture in low memory. And what's neat about later on, we're going to put a different, not low memory, but in block 0. Later on, if we want to, we can put another picture in block 0 and use the same program. And this program, all these Twisty programs, they don't need to have any changes to them because they can read from that program when they communicate, and it knows what to do with them. Anyway, down through here, we clear our screen. We display our picture again, and all the same code, setter mode. Now here's our difference. We've got move 1 and move 2. Remember before the last time I said we end up with garbage the first time it displayed? We're going to do a move 1, move 2 here. We're going to initialize both of them buffers, buffer 1 and buffer 2, which that's the stuff we looked at before. Was all that looping through all that stuff. So we get done with this here, we've got both buffers are initialized correctly. Now, we're going to do a lot different now. So this is the same. Our loop, our vsync is the same. Which buffer we're going to do is the same. Same thing here, display buffer yeah, it's this display buffer 1 and work on buffer 2. That's the same. And here we start out where the difference. It says refresh buffer 2, which is bad too. We're going to go to move 2A instead of 2. Okay, so 2A is down here in the middle. We're not going to do this. Remember up here we put this 30 and 2C in there, and we moved that 24,000 bytes. We're not going to do that this time. We're going to come in down here, and all we're going to do is update the MMU registers to say, here's what we wanted. Here's what we wanted them particular addresses to work with, which is quite a bit of change, because we're not going to do that move in between every screen change. So we're did that. Now we got another one here called erase 2. Load Y with the address of erase 2. Okay, then we're going to load up another field called erase 2 yes. Okay, let's take a quick gander down here at the bottom. Okay, here's our two fields. Erase 1, which is for buffer 1, erase 2 for buffer 2. I just put a yes on the end of it, whatever it is. But 0 means don't erase, and anything on the 0 means erase. Now we got a fields down here. Erase 1 is for buffer 1. It's got the address of on the screen what we're trying to erase, and really it's restoring. So, and then the width and the height, which is a part of what our sprite is. Okay, and it's 8 by 16, so that would be in there. And erase data, whatever, we're going to take whatever's on the screen before we update it, and we're going to store it here. So it'll be 128 bytes here, because we're going to do it in 8 by 16, 128 bytes. We're going to put all them, store that information for buffer 1, and another same series for buffer 2. So if we get back up here to, where was we at here? Load the address of erase 2 and then say, do we want to erase yes or no? The very first time through it says, no, we don't want to erase because it's 0, because we don't have anything to erase. We haven't done anything yet, so it would branch around this here and turn on the erase bit for the next time through. Okay, then it's going to do the same thing we did before. We're going to draw the line on the screen and do some Sprint stuff. Okay, this here is the same exact code. Okay, so we're going to go down and look at Rocket E. I know there's a change down here. The rest of that's the same as we did before. We'll go down here and look at our Rocket E, which is pretty much the same. And that thing up here, it said enter with the address for buffer 1 or 2 and register Y. Okay, so Y has a pointer to one of them erase buffers down there. So first thing we do is, like we did before, we load up our size and we'll store it into our save area into Y++. So that way we've got, first thing we do up here is store the address, the screen address in Y++, and then we store the row column, the width and the height in Y++. So now we'll be able to get ourselves out of this, so we know where to put it and how big it is. The only other thing is down here now is when we get the old, whatever's on the screen, whatever we get on the screen, we load it in A, and we immediately store it in Y. That way we've got a copy for the restore. So now we've got in our buffer down here, we've got the address, this mouse, we've got the address, the width, the height, and 1 byte of this is filled in with what was on the screen. And as we loop through there, putting all this stuff on the screen, whatever's on the screen, we're going to store in this either buffer 1 or buffer 2 to get all 100. So we'll be able to restore at some point in time what we put on the screen. Hope you see where we're going with this. Okay, so we do that. We did the Sprite stuff. When the Sprite stuff is done, it's going to branch back up the main loop. We're going to come back through and do the next buffer, do the same thing. So the next time through here, when we work with buffer 1 and display it and work on buffer 2, we're going to take this branch here the long branch subroutine to restore. Let's see what, take a look and see what that does. Here's restore. All we do is pass Y to which buffer it is. It's either buffer 1 or buffer 2 we're working with. We'll load up the first 2 bytes, which is our address. And then we'll have an address. We'll load up our width and our height, our row column, so we know how to put it back on the screen. We'll push them for our 2 for loops, our width and our height. We'll load up A, which is the first character that was on the screen originally, and we'll store it back to the screen. We'll decrement our counter, and we'll go through there 8 times. As soon as we get across to that column, we'll drop down once, 1 row down, and we'll do the next row. We'll just keep going through until we do all 128 bytes. Restore is easy, so we didn't have to copy 24,000 bytes. All we got to do is move 128 and plug back in what was in that. We took it out of the screen, put something new in there. Now we're taking this back out and putting it back in the screen. So our screen is restored. And we just keep doing the same thing, buffer to buffer. Buffer 1, buffer 2. And just keep, as we did before, we keep rotating through here. Erase out of one, restore the other. We just keep going. That's it until we're done. So there's no sense going any farther, because we're just, that's kind of what it is. We're done. So let's take a look, if we may, at Twisty 2. So remember earlier we run that program for Twisty 1 and we put that picture out in block 0. We'll clear the screen here. Well, it's still sitting out there in block 0. It's been sitting there for a long time. So now all we need to do is load in Twisty 05, which we just looked at. Okay, and it's going to use that. So now we're going to execute it, and you'll see the difference in it. Now remember, this also has the line flashing on, so here it goes. A little quicker. Try it again. You can watch the rocket, or you can watch the line flickering. Again, so we can get a good. Can't hardly see it crossing through there. It's going pretty quick because there's no delay. The only delay is that restoring them 128 bytes in between frames. One more time. Okay, so that was 2 different methods of moving a sprite across what we're doing here. You can choose however you would like to do it. That's up to you. Now we're going to move on with, I don't know how our time is doing here, but I think we can get this in. We're going to move on to Twisty 06. Okay. Twisty 06, the only difference in it and Twisty 05 is this one's going to do 3 rockets instead of 1. So we're pretty much the same. Other code, 99% of it's the same. Up here at the front, we got some more initialization to do. We got rocket 1. We're going to put an address. We'll display it on the screen and set some other erases, addresses to 0. So we're starting out fresh with everything. So we got rocket 1, rocket 2, rocket 3. We'll take a quick gander down here to the bottom and see what that all is like. Okay, I built some objects for these. Okay, rocket 1, rocket 2, rocket 3. And it's got an address where to display, where restore for buffer 1 is for that rocket, and where buffer 2 is for that rocket. Okay, I also did a few equates up here so we could use these addresses, so if we ever needed to change it, we could change it. Anyway, I built that. So we got the same thing for rocket 2 and rocket 3. So rocket 1, he says I got to erase 1A and 2A. Okay, here's erase 1A. This is for buffer 1. Okay, it's got an address, height, width, and same as we had before in Twisty 05, it's got the 128 bytes here. So for buffer 1, this is for rocket 1, which is ABC here, and buffer 2 has ABC for rockets 1, 2, and 3. So we got 128, 128, 128, and so on. Okay, so we got a lot of bytes down there just for restore, but we're going to have 3 rockets on the screens at the same time, 2 separate buffers. So we've got a lot to keep track of. But so by doing it this way, having an object pointing to an object, we can do it pretty simple. Okay, so we initialized all these goodies up here at the front, and now the rest, that's all the same, that's all the same, this is all the same. Get our picture, that's the same. Clear out our buffers and start our loop count. Same, get down to here to display buffer 1 and work on buffer 2. We're pretty much the same. We'll do that move 2A, which we did, which really all it does is move the pointers. It doesn't move any data around. Okay, here's where our first change is. Branch subroutine, do erase stuff. I like that stuff. All right, do erase stuff. Load X, rocket 3, and branch to restore. And then we're going to do rocket 2 and then rocket 1. Let's go look and see what the restore is. It's pretty close to what it was before. We'll look at it anyway. Anyway, we're passing some addresses, so it's got a few extra things to do up here. We'll load up. We're pointing. Remember, we pointed to that object down here, and we don't know what to use. So we're going to start out. We're going to say we're going to default to erase buffer 1. We don't know that yet, and we're going to load up our buffer and see which buffer we're really talking about here. If it's not equal, say buffer 1's okay, go with it. If not, let's do buffer. If it's not buffer 1, let's do buffer 2. So we'll do whichever one it comes to, we'll do that. So now we're pointing to the correct buffer. And now we don't know. Remember before we had that erase buffer 1, yes and no? We don't have that here. What we're using here is, remember at the beginning of this program, we initialized all them buffer addresses to 0, which means they've never been used, because if they had an address in there, or something was in there, it'd either be in the 2000 range, 4000 range, or the 6000 range. Nothing in the 0 range. So here's our code. We're going to load up A with that very first address in our buffer. And if it's not equal, or if it's equal, we'll fall through here to pull. There's nothing to restore because we've never updated it, so we'll go back. Okay, so that's how we're telling if we've ever done that before. So it's not equal. We're going to jump down here. Where to restore? Same as we did before. Where to restore width and height, and go through that loop 128 times to restore it. So coming in to restore, all we have to do is determine what buffer you point to an object. Either it's buffer or rocket 1, 2, or 3, and within there we're going to see which buffer we're talking about. Pretty straightforward. Okay, do some erase stuff. Our next thing will be do some sprite stuff. Okay, do some sprite stuff. We're going to do rocket 1. It's pretty much the same. We'll look at it. We'll display the rocket. Okay, and it's pretty much the same. We did the same thing at the beginning of this one. We load up the rocket 2 erase buffer. Check which buffer we're on. If it's not 2, it's got to be 1. So therefore, we're pointing to that object that would point to, and then we're kind of there. In the address where to display, we'll display. Oh, I'm sorry about this jumping around with my mouse. I need to get a mouse. It's just jumping all over the place. I'm not even touching it. Anyway, our rocket display is pretty much the same. We're doing all that splitting stuff and get the old one, or storing it wherever this pointer with these different buffers are, and just goes through there the same way as it did before. The only difference is determining what buffer, erase buffer, we're using at the beginning. Okay, then we're gonna, this buffer again, buffer 2 again, we're gonna draw that line just so we can see it. No, we're not. Sorry about that. I didn't do it. We just branch always this stuff. We don't need to see it because we don't need to see it anymore. We proved that. We did some sprite stuff, and then it goes back to main loop. Main loop, same as before. We're going to switch buffers, and we're going to do the same exact stuff. Point to an object, point to a buffer, go on through and display. Okay. I think you get the point. I hope you do. Well, let's take a look at that one. And If I can bring this up. All right, we're still using this. We're using one rocket. All three of them is going to display in all places. So all we need to do is load this program. That was 06. So we're going to have 3 of these rockets going across there now. Oops. If you spelled it right, it would work better. Ready or not, here we go. Okay, we're going to go across the time and a half to give better times yet. So that's our 3 going across, not refreshing the screen, but refreshing. Remember, we're doing our save or restore that part of the screen. So there's 3 of them all going. So they're all still moving at a pretty good clip. One more time. Okay. That's 3 of them moving across there with transparency. Let's move on with this here. Okay, one more item. We need to look at one more program called Twisty 10. It has a few minor changes to it, and one thing I didn't mention in the previous one was the way we stacked them on the erase buffers and brought them back out. If you notice here, erase, we do 3, 2, 1, and to put them on, we do 1, 2, 3. The reason for that is if we put them on 1 and they overlap, if 2 comes partially over the top of 1 and 3 becomes over the top of 2 and R1 or whatever it may be, we need to unstack them the same way we put them on. So we put on 1, 2, 3, we erase them 3, 2, 1. The only changes to this program is this few instructions here. In fact, it's just 2. What we're going to do is, instead of bumping over 4 pixels or 2 bytes, we're going to add here, we're going to do the screen width divided by 2 plus 2. So what we're going to do is add to it, we're going to go down 1 line and over 4 pixels. Down 1 line, over 4 pixels on rocket 1. Rocket 2, we're going to stay the same as it was before. We're just going to go over 4 pixels or 2 bytes. And rocket 3, we're going to subtract screen width divided by 2, or go up 1 line and over 2. So we're going to, rocket 1 is going to come down 1 line and go over 4 pixels. Rocket 2 is going to go over 4 pixels. Rocket 3 is going to go up 1 line and over 4 pixels. So eventually they're going to cross. So the only thing that changed in here was this instruction and that instruction from Twisty 6 to Twisty 10. So with that, let's take a look at that. Sit around forever talking about the program. Twisty 10. Remember, we're using the same rocket that we loaded out there a very, very long time ago. So if we execute this one, okay, how about that? Again, it's kind of hard to see, but right there at the very first part of this twisty pretzel thing here is when they converge, and at one point in there, one frame, all 3 are in the exact same place. Very hard to catch when it comes across on the screen, but right in there, they're all 3 in the same place. So that's why you do 1, 2, 3 and 3, 2, 1. Okay, this is getting long, but we've got one more thing to do here. Well, probably more than one, but I'm going to got a basic program called Rocket Show. Okay, look at it real quick. It's a basic program. It's going to load three separate pictures. One called Twisty, which we're looking at, another one called Swipe, and one called Zap. So we'll run that, and this thing's going to run. And it's going to put them in block 0, block 1, and block 2. So we're going to have three pictures out there. Okay, it takes a while to hopefully. There we go. I could execute. I think it. I'm not sure. I think it does. I think it works. Yeah. Okay. That's still that's that rocket or twisty tin. Okay, and I got another basic program here to switch this stuff around. Okay, so we want to run 9 first. And this rocket show.bin, it's the exact same as rocket as 10. I just renamed it. Okay, so that works. So now if I do 2, we'll run it first. All that's going to do is give us a different background. Okay. Remember, this is the same exact picture out there that's been out there for a long, long time. Use a different program, but they communicate back and forth where we can use the same background. So if I run again, I can do another background, which is just something swiped on there, and we'll get the same exact thing with a different background. So I don't know if you think about that. If you have different backgrounds, whether they be mountains moving or ground or inside a building or whatever you may want, you can change the background and your program can talk to it and you can get the same results quickly. Okay, now I got one more option. One that says slow it down, so you can actually, I just put that, all I'm doing is poking something into the program, put a timing loop, slow it down so you can see it as they come together. Bang, they're all together. So it's again, they're stacked 1, 2, 3, and 3, 2, 1. Hope you're not tired of looking at them rockets. But if I do a 2 again at a slow speed, and we are just about done. And when this is done, we are. Again, this is code I did. The way I did it may not be the best way. It works. Maybe give you some ideas where you can think about it and work with it. Okay, do your research. Look at Basic Unraveled. Try. I'm not providing any code because that C program's custom and there's some manual steps in there, and I'd have to write a book to explain everything, but you get the ideas of all this stuff. Again, I started part 1. I'm not an expert. I've done lots and lots of work on this stuff. Research, testing, figuring it out. I mean, I've been programming for over 50 years, so I understand programs talking to one another. I understand the mechanism, but if this is the best way to do these things, I don't know. They work. I'm not writing a game. I'm just writing stuff and putting stuff out there that people can look at and maybe get some ideas on how to use them. I will provide links at the bottom of this here for CoCo SC. You can look at the CoCo Nations tech show. I'll put a link in there on explaining the CoCo SC. I'll put whatever else I need in the links below. So good luck. Hopefully this doesn't help. And I probably will put another piece of this thing out in the future. I thought, well, what I should do is add another sprite instead of rocket, have 2 sprites or maybe even 3 sprites, and be able to work them into the objects where we got 3 different things going on. And I guess I could skinny it down and let it bounce off the walls instead of just going off the screen. But anyway, I think this was a good exercise to let everybody understand how some of this stuff works, and maybe you can go forward and definitely improve on it. So I just thought of a few more things I need to do to finish this up that I forgot to explain to everybody. So there will be a part 3. So look for part 3 of this series.